Today we will start our next lecture, next chapter, that is Coulomb's law, chapter number 2. Coulomb's law, electric field and Gauss theorem or Gauss law. Basically, these are the small chapters which we have discussed or studied in 10+2 class. We have studied Coulomb law as first chapter, electric field as second chapter, and Gauss theorem as third chapter in previous class. So you will do the articles or these laws from 10+2 book or from this book yourself, because same articles are solved here. But I will discuss only those articles which are not covered in 10+2 class. So I will discuss only Gauss theorem or Gauss law. It's also law. It is Gauss's law. So what is Gauss theorem? And we will discuss the Gauss theorem in differential form, because we have simply the Gauss theorem, that is simple Gauss theorem, is E dot ds double integral for whole surface is equal to q by epsilon naught. This is Gauss theorem. You have studied in the 10+2 class. But I will convert this theorem into differential form, that is in derivative form. This is in integral form, but we will convert it into differential form, that is differential form of Gauss theorem. So we will discuss only differential form of Gauss theorem. So this is a new article. Now, how we will convert this integral into differentiation? So it is very simple. We will change or convert left hand side and right hand side into different integral form. We have already studied, that is double integral into triple integral by using Gauss divergence theorem. So using Gauss divergence theorem. What is that? It is nothing. It is the theorem which convert double integral into triple integral. What is that theorem? If there is double integral of electric field, then it will become divergence of that electric field and become triple integral. So this is nothing. It is Gauss divergence theorem. So this theorem which easily convert double integral into triple integral or triple into double. So on the left hand side, I will write this double integral as this triple integral here. Okay. So the left hand side is covered. Now we will convert right hand side. So on the right hand side, epsilon naught is constant, q is variable. So we know that q, what is q? You know that there are different types of densities. Rho is equal to q upon volume. It is volume charge density. And q become rho into v, rho into volume. Rho means density into volume, or this volume may be written as dv and triple integral. Okay, because integral of dv is equal to v. So I have written this v as triple integral of dv. Now we will put the values of this double integral as triple integral here and the value of rho as this value here. So on putting these values in this equation or in simple Gauss theorem, we will get, so for putting these values in this Gauss theorem in equation obtained from Gauss theorem. So this E dot ds, this will be written as del dot E into dV triple integral for whole volume. This one. And the right hand side Q. Q is this rho into dV triple integral upon epsilon naught. Okay. So this equation is reduced to this type. Now there is uniformity on both sides, because on the left hand side there is triple integral of volume, again on the right hand side is triple integral of volume. So we can cancel this triple integral volume on both sides or omit this triple integral volume on from both sides, and we will get del dot E is equal to rho upon epsilon naught. So this is differential form of Gauss theorem. Differential form. So this form has not studied in the lower classes. If we multiply this epsilon naught here, then it will become epsilon naught into E is equal to rho, and this epsilon naught into E, this is nothing, it is new vector D. So this del dot D is equal to rho. So this is also Gauss theorem, this is also Gauss theorem, and simple form you have already studied, that is that E dot ds integral is equal to Q upon epsilon naught. So these are three different forms of Gauss theorem. So this is new formula. After that, we will discuss the next article or next step, next topic in the next lecture, and again the next lecture is also, next topic is also concerned with the terminal 2 class, that is capacitance. So I will not go in detail in case of capacitance also. I will discuss only one or two articles which you have not studied in the lower class. Thank you very much.